Yeah, hello everyone. Welcome to the DataFlint webinar, right on time. So either good morning or good afternoon or good evening, depends where you are geographically. We have attendees from all over the world. So that's cool, and we're excited, and I'm excited. Today, I'm going to chat with Holden. As you can see, she's already here with us. So, morning, Holden. How are you?
Morning. It's good to be here. I'm excited.
Yeah, great. Same. For those who aren't familiar, so Holden is a leading figure in our world of Apache Spark and also, of course, in data engineering in general. You contributed and committed to Apache Spark for years, also on the committee, on the project management committee of Apache Spark. Worked at various large enterprises, right? Had fun with big data for a long time. And of course, you wrote a few books, so we're going to chat about that as well today.
Very excited about the
So
books.
super cool. Oh, perfect. So we'll touch upon that. And the topic of today to our listeners is Apache Spark optimization. If you aren't here for this webinar, so it's time now. It's time you can move to the right one or to the correct one. And just to give you some context, the idea is uh, at the end to go over how we think about Spark optimization, specifically Holden, how we tackle problems, meaning more which frameworks we have in mind, how we think about problems, and we're gonna have a short walkthrough of a small job that has performance problems and chat how we tackle it. That will be later. Also, we're gonna touch about the future of Apache Spark with some interesting stuff there. So for sure, stay tuned. Um, so I'm curious, Holden, if we go to your LinkedIn, you're now running a company, right?
I am, although
Is this still the case or not the case? Tell us like what are your plans in the present and in the future?
yeah, complicated. I would say that there's an announcement coming out tomorrow on my
Okay,
LinkedIn.
so I won't.
But no, it's
We can
okay.
wait with that. Uh,
It's okay. I'm at Snowflake now. I'm still working on Fight Health Insurance in my spare time. It's something that I care deeply about. We tried to make a company, but we did not, in the phrase of Silicon Valley, succeed at raising follow-on funding. And so we built a thing. We got several thousand users, but the economic side of it didn't quite play out. And the thing that I built, of course, I used a lot of Spark building it, but now I'm back to building Spark, right? So at Snowflake, working on Spark again. And before I left to work on Fight Health Insurance, I was at Netflix, also working on building Spark. So,
So first, congratulations, and that sounds exciting. Like I wouldn't have guessed if you like gave me a semi-random option to guess which company. I wouldn't guess Snowflake, but I would say that I've seen in London you went to Snowflake and like open source event, right?
I
I've
did.
seen that, so that was a clue, right?
Yes, that was a clue. And so there's a few other people at Snowflake working on Spark as well. And so there's a small group of us there thinking about how to make Spark work in the Snowflake ecosystem better.
Hmm.
But also my
Super
focus
cool.
is on open source Spark there.
So again, congrats and
Thanks.
best of luck on the new journey.
Thank you.
Um, and I'm curious, so give us maybe like a minute or two about how did you like got introduced to Spark in the first place? Like when was it and what drove your interest in it?
Yeah. So I think there's sort of two two jobs that sort of lined me up to be thinking about Spark. The first was I was at a very small company called Foursquare, which was originally based in New York. but they were probably, I would say, one of the earliest adopters of the Scala programming language, which is the language that Spark itself is largely made in. Even though a lot of people using Spark use Python, Spark is predominantly written in Scala. And so at the time, back in 2011, Scala was not a very popular programming language. And so I got hired at Foursquare. I didn't know Scala at all, but I knew PLT scheme and Java. And they're like, that's close enough. Between those two things, that's like a Scala developer. And then I went to Google, which was a lot of fun. I worked on Google Plus, which was not a success. I think we can safely say that the Google Plus experiment did not succeed, but it was a very fascinating time, and that's where I really got into distributed systems. And so I think between having learned Scala working at Foursquare and then getting really into distributed systems while I was at Google, I was sort of primed for something like Spark. And Spark came along around that time, and I was like, this looks really cool. I wrote a book about it, and then I got hired at Databricks, and I've been working in Spark pretty much since 2014, maybe 2013. So it's been a very long time.
Oh, wow. So the book is the Learning Spark? First edition, actually, right?
There's a book that happened before that one, before Learning Spark. That is thankfully out of print. Please don't go find it. But it was something like Fast Data Processing with Spark. And it was for Spark 0.7 or 0.6 or something like this.
Yeah.
So really, probably before should have written a book because the API was not stable at all. But yeah, so I wrote a book and then joined Databricks, and then I wrote Learning Spark along with Mate and several others at Databricks, and that was a good experience because at that point
that was 2016, right?
Yeah. Was it? I don't actually know. 2014 would have been 2015 probably actually, but yeah, close enough.
By the way, I must say that I encountered Spark later. So previously I was a data scientist, and that's how I got into it. And that's the book that helped me the most, the burning one. Yeah, and I recommend still to everyone to today who want to get introduced to Spark. That's cool.
So there's a second edition of it now, and I'm told there's probably work starting on a third edition before too long. And
yeah, things have changed for sure.
Yes, in the intervening 12 years, the world has changed a little bit.
Got it. And then I'm curious. So a few years later came your book about more Spark and how to optimize, right? And how to deal with. So it came from a personal challenge that usually you were the person that dealt with the hard problems.
Yeah. So I was at a very small company called Alpine Data Labs, which in fact, actually, I just got a notice that their 401k has been dissolved. So the company is very much no longer around. That's their retirement plan is gone. Not that there was much of one, but and we had some very, I would say, challenging customers who wanted very precise answers and would not accept approximations, which is reasonable, right? Like they were, I think, in banking or something like that. So I imagine an approximation answer was not something that they could work with.
Yep.
And so because of this, we had these like kind of really gnarly problems of how do we provide these answers for them relatively quickly. And that's where I met my co-author, was at Alpine Data Labs. She is now a grad student. Maybe she's graduated. Last we chatted, she was doing a PhD program. but she could have graduated anyways. And so worked with her and some others on these problems, and it was like really fascinating. I was like, you know what, we should write a book about this, because like this is a different way of sort of thinking about the data problems than I'm super used to, and I bet it's probably different than other people are used to thinking of it. So that's sort of what caused us to start writing the book. And then, of course, it took us way longer to finish writing the book. I would say that we solved the technical problems, and then writing the book probably took 2 years after we were like, yeah, let's write a book. And then 2 years later, we finished. Turns out it's a lot of work. It's fun, but a lot of work.
Yeah, and somebody asked in the Q&A the name of the book. So the name is High Performance Spark, right? That's
Yep.
the original name. Cool. So to
Yep.
those who asked, and that's before LLMs for sure, right? So people today are
Yes.
used to write easily. Back then you had to actually, think about each sentence and then a paragraph and then rewrite and iterate.
Yeah. I
Was
mean, I still
a
think you probably
process.
should for the most part, because with LLMs, it's just not the same. But I'm I'm biased. I'm biased.
Oh, we'll get to the point when we talk about code. I would like to hear your thoughts about what do you think about that, but we'll get there. So cool. And nowadays, or there's an incoming second edition, right?
Yep. We've been working on it
When
for
is that
several
planned?
years. Yeah. It should come out sometime this year, probably pretty soon. It's in tech review right now, and you've actually contributed a chapter to it, which is amazing. Thank you so much. Really excited. Uh,
Yeah, so thank you for the opportunity. Yeah, that's something probably nobody knows about.
oh, I'm
So
sorry
to
if
those,
that was supposed to be secret. My bad.
but now it's out there and cool. I'm happy to share it as well. Yeah, about a chapter about the Spark Web UI,
Yep.
which is super cool, and we're gonna see a little bit of this today later in the webinar. Yeah, thank you for the opportunity. And by the way, as we promised, we're gonna, after the webinar, out of all the attendees, we're gonna randomly choose three, and they're gonna get the second edition once it's out. So that's also fun. And to all of those that are today with us already, we're approaching 100 people live. So that's
Oh wow.
yeah, super cool. Um, and by the way, I'll add a few words about how we met and how let even which led to us talking today. So actually, I reached out to you around a year ago because I was coming to San Francisco, and but it wasn't about Spark. You remember?
Yeah. Yeah. You wanted to know about different things.
Yeah, about dancing. Yeah, yeah. I'm a big fan. Uh, and that's how I reached out, and we stay in touch, and we met for coffee. So that was almost a year ago, and that led to the webinar and also the chapter in the book. So I'm super grateful, and just shows you, like in life, how things come out. I wouldn't say randomly. It's not random, but not at least where you expected.
Yeah.
Yeah.
Yeah. The small the small connections are magical.
Cool. So that's the book about Spark and performance is a great segue to our main topic. So I would like first, before we talk about it, how would you define, you called it, high performance, or this webinar is optimization. What does
Yeah.
it mean to you?
So I mean, I think
Let's
high-performance.
define the concepts first that in the language we use.
Yeah. So when I think of high performance, it's being able to do more than sort of the stock, or more than just the baseline. So it's everything where we're taking a system and we're sort of pushing it to its limits, and maybe beyond what people thought its limits were. And so, that can be doing all kinds of funky things. It can be tuning parameters. It can be rewriting code. It can be all sorts of different things, and so you'll do various optimization techniques to build a high performance system, and that's sort of we can think of optimization as the process which lets us build a high performance system. This is how I think of it.
Yeah, got it. Because I'm asking because in a sense, like the knee-jerk reaction would be, okay, like Spark is built to be high performant, right? So yeah, of course it's not there out of the box, but I shouldn't work too hard on making it performant or optimize it.
Yeah, I mean, I would say that in general, right, like Spark is relatively high performance, especially compared to sort of the systems that it replaced. Uh, but you know, I don't know. I like, and maybe this is just I spend too much time around people who like cars. It's like you can have a really fast car, but like when you think of a performance car, it's like someone has done something extra to it to make it faster, right? And it's the act of doing something extra to it. Um, and I think the other thing is there's a few software truisms, right? Which is, you know, 10% of your code is responsible for 90% of the time, right? And so we can make parts of it go very fast, but if we make the wrong parts of it go very fast, then no one will notice, and we haven't really done anything meaningful, right? It may have been an interesting academic exercise, but because it's not the part that matters, and that's something that we struggled with back when we were solving those technical problems for that banking customer. We would find parts and be like, oh, I bet this part's slow. Let's make it fast. But, because we didn't measure it properly initially, our bets were wrong. And we made things that didn't matter fast. Yeah.
Interesting. So they didn't define like what they want to optimize or fast, like you had like SLAs around time of queries or jobs, or it was more like a cost perspective. They wanted, it was too expensive, cluster too big.
Yeah. In that case specifically, it was we need the answer as fast as possible, but we're stuck with at most the resources that are available on this cluster, right? So normally when someone just says like, I want the answer as fast as possible, we can just throw money at the problem, right? It's like, okay, Spark is pretty good at parallelism. We can just rent more computers. Amazon will rent us more computers. Google, whoever you want, they'll rent us more computers. But it was, we want this answer as fast as possible, but for regulatory reasons, this is the place where it has to run. These are the machines we've got. Make it fast. And in practice, even when people say cost is no object, it often turns out that cost is somewhat of an object once you actually present them with the bill. So I find it's useful
Yeah.
to find out what those limits are in advance.
Yeah. Got it. The way I look at it, which most people do, it's either cost or like runtime, right? Of course, they're coupled,
Yeah,
but oftentimes there's demand either on this or that one from
yeah.
stakeholders or whatever.
And there are times when we can reduce both,
Got
right?
it.
Like, but not
Mhm.
not all, not all.
Yeah, that's why I say it's coupled. It's not like it spans two different things. Of course, there's a huge connection between them. But I'll double click on what you said, like throwing more compute. That's like the first thing you do, right? Something either
Yeah,
again slow, you throw more compute, or even sometimes it breaks. And okay, I'm gonna increase the cluster or increase the RAM of my machines and pray to the gods of Spark that it runs now. And we see it a lot as a first solution. And maybe 80% or 90% of the time it works, but
yes. Sometimes though you have right, which I'm sure we'll get into more. you have like an individual partition which is slow, and inherently your problem is like the unit of parallelism doesn't work here, right? And then throwing more compute at it just means you have more computers sitting idle, right? And so at that point, you have to sort of revisit, you know, how you're splitting up the work so that you can actually take advantage of the parallelism, right?
Yep, agreed. Cool. So having defined or semi-defined how we look at things, uh, I would share the screen, and we can. There is some code, nothing crazy,
Sounds great.
in PySpark, and then we're gonna open the web UI. And while I'm doing that, I'll open a quiz. Well, it's not a quiz because there's no right or wrong answer, so it's more like a poll.
Okay.
Let's press launch, which okay, and the question is, when was the last time you used the Spark Web UI? Oh, wow. I see already like 20, 30 people answered.
It won't let me vote.
But can you see the results?
No, no, it doesn't show me the results
Maybe
either.
just me. And
Yeah, you get the
I'm the
secret
host
detail.
and I can see. Let's see if I can share it to everyone. No. So already 60 people answered. I'll let them everyone answer until I'm sharing the screen. So just a second. In the Q&A, I have a question. When will Spark optimization webinar start?
Hopefully soon.
Okay. I don't know. Maybe the person went back in time or something. I don't know. But this is the webinar in case you still are considering what to do. Okay. Let's see. Okay, I have cursor. Okay, I'm gonna share screen. Okay, Holden, can you see it as well?
Yep, we're here. We got some code.
Perfect. Yeah, so we have example with I think like 10 or 9 performance issues.
Mm-hmm.
We won't do all of them. Even here it says what, like in the comment, what's the problem.
Yep.
So here we repartition data to 100 partitions and save them into files. So we get like 1,000 small files in this DF write. So in a sense, I would like to focus on um, that query. There are others here. Then we read them. We do some stuff that causes more problems. But as we have time that is limited in the webinar, I would recommend doing that. So I would say priors, we see DataFlint. Often this problem, meaning some jobs wrote small files and then like another job because maybe they have some kind of pipeline that is orchestrated. So the next Spark job reads small files, and then like the problem propagates and causes bottlenecks. So that's, in my opinion, a great idea. And right, you look at the code. Well, here it says we're creating small files, but usually or always you don't have it
Yes, most people
explicitly
don't leave.
written as a problem. Curious, how often did you stumble upon problems with performance of small files?
I've seen a fair number of them, mostly on the not so much with the file I/O itself, although that is certainly a part. The part that I've seen tends to come from post ingestion when we just end up with like all of these tiny little partitions which just really don't make sense. And that's yeah. But
So
I've
when you mean a tiny partition is more like we have data skew and then some of them are too small, or that's something else?
Oh no,
or
like we'll
partitions
end
queue?
up with like hundreds of thousands of partitions, and it's just because so when you read from RDDs, right, you get to have backing
Mm-hmm.
that represents the files, and so um, when we've got all these tiny files, uh, sometimes we end up with sort of partitioning that matches directly what our input was, and then we have a unreasonable number of partitions. With data frames, the default repartitioning normally solves this problem for us pretty well. Uh, there's still some downsides at the I/O time, but in the RDD land, we'll end up with sort of an unreasonable number of partitions, and there's a small overhead for each partition. And then, especially if you start doing things where you're trying to optimize, connections on a per partition basis or stuff like that, all of these really cute little optimization tricks that you do sort of stop working because the number of partitions you have is no longer reasonable. And so, like this cost that you thought you were amortizing is no longer really amortized because you just have a ridiculous number of partitions. Um, I see this mostly when people are trying to be smart, right? The danger comes there when you're trying to be smart, but you don't think about it all the way through, because it's a very natural thing to try and sort of be like, oh, my job is slow. I want to increase partitioning, right? But there
Mm-hmm.
comes a point when you push it too far, and I think this is probably biased to people will tend to come to me after they've already tried to fix it a little bit, right? So after they've already worked on the problem for a while, and it's more likely that they've done some things that didn't work, which is probably why I see sort of weirder cases than I think are normal.
Holden, you're a little bit choppy. Can you hear me?
Oh yeah, I can hear you. Sorry about that. Let me see. And
I can hear you a little bit choppy. Can you hear me?
I can hear you. Let me. I'm just going to ping the router quickly. It looks like it's
Okay, yeah, I
fine.
don't know if it's on my side or your side.
Uh, not seeing any network latency. Um,
Yeah, now I can hear you.
okay. Well, joy. Yay. Magic. Fun.
Yeah, so I heard most of the things.
Okay.
You were talking about increasing the partitions.
Yeah.
I guess it's like the shuffle partitions.
Yeah. And the problem is when people just keep increasing the partitions, um, like this, you end up then with reading all these small files or writing all these small files. And then
Mhm.
similarly, um,
Yep.
if you don't repartition the data after reading it, or you're not doing it with data frames with the like partition target partition number, then you can get into the place where someone upstream of you has increased the number of partitions because they wanted to be helpful. Maybe they tried partitioning the
Mm.
data by date, right? But it turns out that there's a lot of dates. Especially sometimes people will partition it by hour, and it turns out that there are many, many hours. And so that can make sense. For example, like if you were storing Netflix's clickstream data, you would definitely want to partition it by hour. Or I shouldn't say definitely, you would likely want to partition it at a very granular level. But if you were storing something less granular, doing it, with less volume, partitioning it so granularly would result in actually bad performance. So it's like this inconvenient thing where like the right thing to do isn't always the same thing, right? Which is part of why the computer doesn't do it for us. Um, so it depends about knowing what your data is like.
Yep. I think a lot of the optimization process is knowing your data.
Yeah,
Uh, so, and last question before we move and tackle the problem of slow files. Um, like, what is your recommendation for file size? Assuming like we're using Parquet files. Do you
yeah. I
have like
mean,
a general rule of thumb?
once again, it sort of depends on what your use case is. I think if your file size is under a gig, you are probably too small. Um, it's like I think like a gig is normally like 1 to 2 is a pretty happy size for a lot of use cases, but it depends on what you're doing with your data. Like if you're doing super complex transformations and you are the only consumer of your data, then you might want smaller file sizes because you
Small.
can more closely match the partitioning downstream. Um, and I think so. There's sort of two things to think about. It's like how is your data inherently partitioned? Like what are the different attributes of your data? But then also how are the people who are going to be consuming the output of your system? Like what are they trying to do? Right. So for example, in the clickstream thing, if people are going to be looking at things in the past week, then we want to make sure we support that really well. But if people don't care about time, if they're always going to be looking at, say, for example, everyone by country, then even if you end up with some small files, maybe partitioning by country makes more sense because that's the metric along which you're queried, right? Going back to like sort of database index days, right? So thinking about
Yeah.
how people want to use your work.
Yeah, sometimes they do it, but like by company.
Yeah,
That's also a case when you have customers that are small, so you get like small files, and you have one huge customer, so you get a lot of files there, or sorry, size. Okay, cool. So let's move on. So again, for uh, our example, I ran it. Here I explicitly repartitioned to 1,000 and then wrote the Parquet files, and I'm running the job and it's slow. What do you usually do, right? I have my answer. How you tackle slow jobs, assuming that they're running, right? No errors.
yeah. So I mean, assuming that it's running, we would probably want to go and look in the Spark UI, right? Because normally the code is not laid out this nicely, right? Normally we don't have it so beautifully laid out. In this case, okay, yes, we can see immediately, we know what the number of rows is and we know the number of files. Actually, we know an upper bound on the number of rows and we know the number of files. So we can just quickly decrease these numbers. But in practice, normally we would want to go look at the UI and sort of say like, cool, what's happening? And then we would see like all of these little tiny jobs. And maybe this is when we go look at the UI. I don't know.
Yeah, that's a perfect segue.
Fantastic.
And was exactly the question in the poll, and 90% of the people answered. And third, open it today. Another third this week, and the rest are spread out. So the audience is familiar with the web UI, which is cool because we're talking here with people who are curious and interested in performance. Because I must add, I guess most users of Spark, specifically now you have Databricks and other platforms,
Yeah.
they don't get to press the Spark web UI, and if they do, they get a mini stroke. Or something akin to that, I guess. At least that was my experience the first time I tried to read the web UI.
The web UI is a little rough. I think we can agree that it needs some love. And I see here you are still running on Spark 3.5. We have to get you to
Yep.
upgrade.
Two, what do you recommend?
Well, actually, so I think this is an interesting side note. So I think actually Spark 3.5 officially goes end of life later this year, but I'm making a proposal later this week that we should extend support out for another year in the open source because I think in practice most people are still on Spark 3.5 and they haven't had enough time to migrate to Spark 4. So I'm going to be making a proposal for that. So I find it interesting that you're on 3.5. But yeah, I mean,
Cool. So
for the book, we've
noted.
tried to retarget the book to 4, just because
Mm.
we want it to be something that can live for a while, and it's the latest major version.
Yeah, I heard some people had minor issues in the migration due to
That's
various changes in
Yeah.
configs.
This is pretty classic.
Yeah,
Migrations are a place which are super painful, especially, and this is the double-edged sword with building high performance systems, right? Like, you tend to do things that depend on undocumented or not guaranteed behavior, right? So here, for example, the repartitioning, that's fine, but like uh, between Spark 2 and Spark 3, um, if a table that you were writing out to declared a sort order, this would actually introduce a global sort into your job, right? Whereas
mm.
before that wouldn't, and it would be up to the user to do this. And these new global sorts that were getting added could cause performance regressions, and were much more likely to impact jobs where people had spent a long time like fine tuning where they were doing the sort and making sure that like everything was just lined up, just so. But when they went to upgrade, there were these new things added that broke a lot of the high performance stuff. And it's sort of counterintuitive, but it's a good reminder of like, if you don't need a hot rod, don't get a hot rod. Like, get a Kia. If you just need something to work, and it's not terabytes of data, or it doesn't have to be incredibly fast, probably don't
Yeah,
need to.
if you don't need a race car, don't get a race car. Back
Yeah,
to
because the race car is going to break. It's going to be fun, but it's going to break.
by the way, you can generalize this a little bit to Spark. I often got approached, and people ask me more like general data architecture stuff, and they want to use Spark.
Mm,
Depends on the use case. Maybe you don't need like a race car, right?
yeah.
Or so for sure, I want to add something. So here, by the way, you can see I went to the SQL data frame tab, and I think there's 10 queries in the whole Spark application. And one tip that it's not an optimization tip, but it helps us humans is give descriptive names.
Oh my God. Such a big thing. Back at Google, in a system that predated Spark, I used to joke that if you didn't name your applications, the site reliability engineers would find you and steal all your whiskey. Uh,
That's great because from my experience, and we have many customers, almost nobody does it. And here you can see it here in the
I
context. You do
love
set job
this.
description. You can write down whatever you want.
Yeah,
And
setting the
then,
job description is amazing. This is always do this whenever you can.
yeah,
I
so for
love
sure, that's like take one tip from the
yeah.
webinar that's gonna save you a lot of time because usually you have a list here of queries with, names that are Java, something Scala, whatever it's
Oof.
named.
Yeah,
And go decipher even where to focus, right? So in our case here, there's a name and it's descriptive. It said it says here, let's see, I don't remember. Oh, write in 1,000 small files, right? So if I'm pressing it, it's gonna take us to the query that does scan Parquet, and then all code stay, gen, exchange, because there's the repartition, and then we write it here.
yeah.
So I'll just say again, most users, in order to understand, there's so we know a priori there's a small files problem, right? But usually you don't.
Yeah.
Um, and here you can maybe find some information about how many files we wrote. Maybe I don't remember exactly. Uh, I'm
I mean,
curious.
the big thing, right, in terms of like if you were looking at this, is that we see everything is taking 0 milliseconds, right?
Yeah.
Um, and that's, you could be like, oh, this is good, but it's not, right? Like when things are running that fast, it means that
Mhm.
all of our time is spent in the overhead, right? And so that's like the first. sort of glimpse that there's something wrong here in my mind. In my mind.
Cool. That's a great point. And by the way, you said about the web UI needs some love. This is the DataFlint open source. So if you can see here, there's another tab. So if you go, we have our open source. Here I'm showing it. Give us a star. And by the way, it's quite already widespread. I think we have at least 20 out of 500 Fortune companies using our open source,
Cool.
which adds this tab. And then again, we support all platforms. In this case, this is Databricks, but I don't get any money from Databricks. The open source works on all platforms. And the tab, once we press it, we can see also there's 10 queries ran, one is broken, easy to filter by the time. But if we go to the one that wrote small files, we visualize the query in a way that is much more human readable.
Mm-hmm.
Okay. So you can see what's happening, each stage, how many tasks ran, how much time it took, actual duration, and like wall clock. And then we can see here, we have this stage that is writing the small files. And here's the repartition that does it by round robin. And we can see it's red. So that's where the bottleneck is. And actually, there's even an alert. So we tell you the average file size is 7 kilobytes. And we have even a recommended fix, maybe repartition.
All right. Yeah. And I like that
Which
it's a
again,
call
in
out.
this case, it's stupid because we prior did the repartition to 1000, and now we're telling you to partition to one again. So you still need to understand what you're doing. Yeah, sorry, you wanted to say something.
It's good. I like the call out that it's unpartitioned files, right? Because there are reasons to write out a lot of small files, right? And so it does call out that like this is not writing out because it's targeting some particular partitioning scheme. It's just
Exactly.
writing out randomly partitioned small files, which is much more likely to be a problem, right? And so that's a good
Yeah.
call out.
Yeah, thank you. And as I said, sometimes you want a partition by the company because that's the business,
Yeah,
request, and then you're gonna get some small files.
yeah, and that's okay.
Yeah. So yeah, and then it's okay. Exactly. So we always go back to understand your data. That's super important. Understand like the business or requirement, what you're trying actually to achieve downstream. And we also hear again a lot of other stuff. We help with understanding like your cluster, and this is a nice heat map. So sometimes the query is huge. So then we have the heat map here, and then you can focus on what's relevant and stuff. So again, super cool. I highly recommend. So due to the reason we don't have a lot of time, I would just say a little bit about us quickly. That's our website. We have our open source, as I said, but we have a product. And then it's a copilot that helps you chat with your Spark expert. So not me, not Holden, but an LLM, but he knows your production context, right? So actually, you here, I'm not going to show it, but I can chat and he can fetch the production logs and give you the exact questions or whatever answers to your questions. So that's a little bit about us. And I want to dovetail the discussion or move it towards the future, right? So in a sense, what we're doing is in the future and a little bit in the present. And I'm curious to hear about the recent vote that you had about your idea for Spark. And so tell us, the listeners, a little bit about that.
Yeah. So totally. So there's a recent vote, and actually there's sort of there's going to be another one happening soon that I alluded to with Spark 3.5, which I think is a version of the future, but is not entirely right. It's more or less like we need to give people time to catch up to our future. And so if you have opinions about that, you can come and join the Spark developer mailing list, and it's open to everyone. Actually, if you go to spark.apache.org, under community, mailing list and resources, you can find where these things happen. There's the user list and there's the developer list. And here, I think it's a place where even if you are like primarily a user, it makes sense to subscribe to the developer list if you've got the time. If you don't have the time, no worries. I get you. But so the version of the future that I'm really excited about is something called UDF transpilation. And this was very recently approved. There's a proof of concept PR, in fact, that you can go look up on GitHub. And if you go into the developer list archives, you can find a link to it as well as the proposal. But essentially, for projects as big as Spark, we had a problem where like people would go off and like build a feature over like 6 months and then come back and be like, look, I built this really cool thing. And then sometimes people wouldn't like it and then they'd be sad because they just wasted 6 months. And so we added sort of a process for these bigger changes. And this process is called the Spark Process Improvement Process. I think I said process twice.
Yeah, it's the SPIP, SPIP. I don't know how you call it.
Spark, I don't know, whatever. Who knows?
Yeah, process something. It's a Google doc with stuff and proposals.
It's a Google doc and a Jira. So all the things that we hate about our life, but in open source. So the most recent proposal that I submitted and got approved is that we should try transpiling Python UDFs. And so essentially, there's this really big performance bottleneck in PySpark, which has gotten better thanks to one of my former coworkers' work, where we've made it less expensive to copy data into Python, but it's still kind of expensive to copy data into Python. And even more so, Python is a wonderful language, but it's not particularly fast in and of itself, right? Like the parts of Python that are fast tend to be the parts that are calling out to C or Java or like another language to do the actual work.
It's okay. Right? We can say that here. It's a safe space. You can.
Okay. Well, it's being recorded, so but like I do love Python. It's a great language, but it is not always the fastest, and it's slow. And so the idea is, what we can do is we can take the abstract syntax tree, and so that's like a tree representation of your software. And if it is something that's simple, right? So if you're just adding two numbers together, or if you're looking for a string inside of another string, or if you're doing some simple kind of work in Python that could be expressed in Catalyst, which is the internal sort of representation of all of the data frame operations. So the hope is, if you're doing something that we could express in Catalyst, what we do is we take the Python code and we shift it into Catalyst code, and then it will run so much faster because the data won't have to be copied into Python, and Spark can optimize it and it can see what you're doing. And this is a really big thing, because when you're doing things in Python, Spark doesn't really know what you're doing, right? So if you're only using a little bit of the data, Spark doesn't know that necessarily. It thinks like, hey, maybe this person is using the entire row, right? And this could be very bad. And this can actually going back.
Yeah, so that's the problem. Just to the listeners, the problem is oftentimes when there's a UDF, well, UDF, with Python, it's a black box to Spark.
It's a black box and it's slow, right? Even if it wasn't a black box, it's still slow, right? And so by transpiling it, we make this black box into a white box. So the Spark optimizer can do really smart things, and we can evaluate it entirely inside of Java. Or if you're using something like NVIDIA Rapids, it can be potentially evaluated entirely on the GPU, right? Because they have things to take Catalyst expressions and convert them into CUDA. And so it's really cool.
Yeah, or other accelerators, by the way, right? We have Data Fusion, Comet.
Yeah. So maybe it'll be evaluated entirely in Rust, and that'll be so much faster than either Python or the JVM.
Yeah.
Well, yeah.
By the way, I just wanted to add about Python. So in my opinion, in a few years, those who know Python syntax, they're gonna be named like low-level software engineers because they know the, they're close to the metal.
I mean, I think it is true that we have a new layer of abstraction coming, right? And
Yeah.
I think that's it's both good and bad. I think for people like me who do systems work, there's going to be a lot of things that are not going to be very efficient that we will have to make efficient because the LLMs, like, it's hard for people to think about the stuff that we're talking about here today. The LLMs can't really think. All they can do is pattern match, and they're not going to make particularly efficient Spark code. They'll make Spark code that works, but they're not making fine-tuned optimizations. And so I think there's an interesting time in fixing the mistakes of the LLMs. Repeat this tip as one line. Okay. I don't
Yeah.
understand. Yeah.
No, cool. So there's a lot to unpack and chat about. Maybe that's a reason to chat again in the future. We have like
Cool.
8 minutes left, so I wanna use that time for the Q&A. We got
Yeah.
20 questions in the Q&A, so I'll try to like
So
find the interesting ones.
is it okay if I grab the last one that was just asked about liquid partitioning?
You can see all of them, so yeah, for sure.
Okay, I'll grab that one while you pick out the next one, if that sounds good. So I think liquid partitioning is really cool. Um, I would say that it's still worth it to understand the distribution of your data, right? Because if you don't understand the distribution of your data, you're going to write things that liquid partitioning is going to struggle with. Um,
Hmm.
and like, so for example, going back to what we were doing initially, right? Like, liquid partitioning isn't going to fix a group by key where you then iterate through all of the records with a single key, right? Um, it's not going to be able to fix that because fundamentally this operation is slow, and it's a fine operation, except if you have massive key skew in the one parameter that you're thinking about. So I think liquid partitioning is great. It reduces how much we have to worry about it, but it doesn't reduce it to zero. It's still important and useful to have a broad understanding of what the distribution of the different columns is that you're working on, especially around things that you care about.
Mhm. Got it. And somebody asked that the event was advertised as 3-hour workshop, so that wasn't our intentions.
Oh,
So sorry if somebody got, yeah,
my bad. Yeah, I don't have
if
three
there
hours.
was
I have
some
to take the
mistake.
dog for a walk.
Yeah, for sure. We have another 7 minutes. Um, Somebody asks, related to the Python conversation, if you're using UDF and Lambda, meaning
Yeah.
on AWS, then PySpark speed comparable to Scala.
No.
What are your thoughts? Is that's like a question? Okay.
Yeah. I mean, the short answer is no. It can be where, like, so if you're doing a transformation, it can be not bad, right? Like, and not everything has to be incredibly fast, right? Like, going back to the, like, optimize the things that need to be fast. You don't have to optimize every lambda expression, right? The question is, like, is this lambda expression the source of your pipeline slowness? And if it is, then it's worth thinking about it. And if it's not, then move on. So many things broken to fix in this world.
Got it. Um, quick questions. People ask if the recording will be shared. Yeah, it will be on YouTube. We're gonna send it after the webinar as part of the email. Also, we're gonna share all the resources. So link to the book, to the SPEEP, to what else? To our open source. So everything will be in the materials after the webinar. Somebody asked a great question. Why won't you open source? I guess our open source and add it to the Spark open source.
So it is open sourced,
Never
right?
thought about that. Maybe, yeah. Meaning make it part of the official Spark distribution.
Uh, yeah.
Yeah, you
I,
don't have to answer it. Somebody raised it. We can chat about it later. I never
yeah.
thought about it. I don't know.
Adding things to Spark
Let's
is kind of
see.
right. Like as someone who does that day in and day out, it's a lot of work. But right, like Spark does have a good history of adopting things that were built outside of it, right? So, for example, Spark on Kubernetes support started outside of Spark.
Mm,
Um, Same thing for a bunch of ML stuff. It's pretty common for open source projects to start outside of Spark, and then maybe be integrated in full or in part into Spark later. But doing it initially for a new thing is kind of slow, um, especially the
yeah.
web UI. It's a rough, it's a rough space.
We have a technical question, which is
Oh, cool.
I'm curious to your thoughts. Somebody says in his code, he has a lot of chained joins and transformation one after the other, and then a single write action at the end.
Yeah,
How would you pinpoint which like transformation is causing the slow or the performance issue? How would you tackle this problem?
yeah. So this is a good question, and so essentially this comes down to Spark being smart. So when you have a bunch of transformations, Spark will pipeline these together as much as it can, um, which is fantastic. Except it does make figuring out which part is slow kind of hard. And so what you do is in that very brief sort of while you're debugging it, you make it so that Spark can't pipeline between the two different operations that you're curious about. And you can do that by introducing a cache block. You can do that by switching it into an RDD if it's a data frame. You can do that by persisting to disk. You can do that by having counts, just like do a bunch of counts throughout your code, see which one is actually taking longer. There's a whole bunch of different ways to sort of cut the graph, and then you can see which part is misbehaving. Because
Thank you for that.
when it pipelines everything together, you're yeah.
Yeah, my liner is use our open source. You're gonna see it right away, which transformation is the bottleneck. We have a great question by Ronnie, and he read your book, and he
Cool.
said at least the first edition. And he says it goes in depth into RDD transformation and their use cases. And he says
Mm,
currently data frame operations take center stage. Did we
yeah.
lose key optimization routes by ditching RDD? Should we fully trust Catalyst to optimize our jobs?
Okay. Interesting question. So I think no, you should not fully trust Catalyst to optimize your jobs. Right? Catalyst is going to be right most of the time. Right? It's a better car, but it's not inherently a high performance car.
Maybe it's a better engine
Yeah, yeah, better
for the
engine,
car.
but you will still sometimes want to do things to it. And in those cases, you can provide hints to Catalyst, right? It has the ability for you to do that. And there are
Mhm.
also times when Catalyst will just do completely the wrong thing, and in that case, that's why there's the RDD escape hatch. And so you'll see this in a lot of high performance code where there will be a large chunk of Catalyst or data frame code goes into RDD land, does something really weird, super specific, and then comes back out and goes back into Catalyst land. And in fact, if you look at some of the Spark machine learning libraries, that's also not an uncommon pattern where they'll like the like normal or reasonable things will be done in Catalyst. But then, for example, in ALS, where it starts building up a really huge query graph, does a whole bunch of really weird things with RDDs because it's doing really weird stuff, right? So in the places where you're doing things that aren't normal, you are more likely to have to go to RDDs. But that's okay, right? Like you can go to RDDs in the few places where you really need it.
Cool.
But you should use
Thank you.
Catalyst for the most.
Yeah. Thank you. That was an interesting question. We have a few others, but our time is up.
Yeah, I can run over by like a few minutes if we want to answer a few extra questions. But
so I have okay, cool. So let's do it. Let's try to do another two questions. So one is by Choi. It says another approach to making the transfer to Python cheaper would be to make the internal data in Arrow instead of Tungsten. Is it realistic to make the internal data format based on Arrow?
This is a fantastic question. I love it. And I think it is something that might happen. It might not. But I think it's a decided possibility. I think though the important thing is that it's still even when we have the Arrow UDFs, right? It's cheaper, right? Like we don't have as much of a serialization cost. And I think there's potential. And in fact, actually, if you look at sorry, my brain, Arrow Data Fusion Comet, right? Like it uses Arrow for a lot of its representations. And so I think there's a chance that we'll see things like that lowering the cost to Python. But I still think going into Python has sort of this inherent slowness, unfortunately, just because the Python operations are not as fast as the equivalent JVM or Rust or CUDA operations. But it's a great question, and I think it is a decided possibility. Probably not soon, though. Like not this year. Not this year.
Is there like an SPIP in that direction?
There's no SPIP for it yet. I think it's a possibility. It's probably not something that I would do personally, just because of sort of my focus. I would expect it to come out of the Apple people, maybe. I think there's a possibility there, but it really comes down to does someone have the time to make it happen? And I don't know about the answer.
Cool. And last one that's also interesting. By Chanukia. I hope I pronounced it correctly. So Spark dictates the Scala version for the entire ecosystem. And he says it's a hard bottleneck. So given that Scala 3 dropped 2 years ago and Spark still won't move, what should data engineers expect? Permanent Scala 2.13 lock-in, or are there any realistic paths forward?
So I think what we've seen happen previously is that Spark moves slowly to new Scala versions, in part because Scala versions have historically not been particularly backwards compatible, right? And that's a very real concern. I don't think we would see anything happening until at least Spark 5, right? Like it's not something that you can change in a minor version. I think there has been progress made at making Scala more backwards compatible, but I suspect we'll have to wait for someone from either the EPFL or Lightbend or similar to come and help, just because that's what's happened historically with all of the other changes. But it could happen, and I do appreciate the work that they're doing to keep Scala 2.13 running on modern JDKs and JREs, right? So I'm not overly concerned about it, but I don't think it's going to happen quickly. But yeah, cool.
Perfect.
Awesome. Thank you so much. This was fantastic.
Yeah, thank you for your time. That was super fun. and enjoy your walk.
Thank you. Thank you. I will. Okay. Talk soon.
Thank you, everyone. See you next time.
Especially thank you for asking questions. We really appreciate that.
Yeah, they were really cool. Bye.